Hello, today I'm going to go over the 2012 Calculus BC Practice AP exam. In this video I will be going over the multiple choice section part A, which is the no calculator section. And so let's get right into it. So first up, we have y equals sine cubed of x, okay? So how we can find the derivative is we can rewrite this as sine of x, and then you cube the whole thing. That's the same thing as sine cubed of x. Now to find dy dx, we can use the power rule first, so bring this down and subtract 1. But then we have to multiply by the derivative of the inner argument, so let's do that. So when we use the power rule, we get 3 sine of x squared, which would be the same as sine squared of x. But then the derivative of sine is cosine, so we multiply by cosine of x. And so when we look at our answers, we see that 3 sine squared of x cosine of x is what we have here, so our answer is E. Now for number 2, we have a parametric equation, so x of t equals t cubed minus 3t squared, and y of t equals 12t minus 3t squared. Okay, so let's find the derivative. So x prime of t equals, let's use the power rule here, 3t squared minus 6t. Now y prime of t, that equals 12 minus 6t. Awesome. So let's try and find when the time t, where both x prime of t and y prime of t are equal to 0. So let's see if we can simplify x prime of t a little bit. We can take a 3t out of everything, so 3t, and then we multiply this by t minus 2. Now this will be the same thing as what we had in our original derivative. So now we can simplify y prime of t. We can take out a 6, and then 6 times 2 is 12, and then 6 times t is 6t, of course. So 6 times 2 minus t, that's how I simplify. So for values of this that can be 0, we have to just look at these terms individually. So if 3t equals 0, then the whole thing is 0, because that's how 0 works. So t could be 0, but it also could be 2, because if you multiply everything by t minus 2, and t is 2, it's just going to be 0. So 2 is here. But now when we look at this, the only time that can be possible is t equals 2 for t equals 0. So our final t is 2, but we're not done yet. So we have to find x of 2 and y of 2 and see what they are. So x of 2 equals 2 cubed minus 3 2 squared. So that's equal to 8 minus 3 times 4 equals 8 minus 12, which is equal to negative 4. So that's our x-coordinate. Now y of 2 is equal to 12 times 2 minus 3 times 2 squared. And that's equal to 24 minus 12, which is equal to 12. So our final coordinates are negative 4, 12, and this looks like answer A, so A is our answer, negative 4, 12. Awesome. So here we have to do an integral from 0 to 4 of this function. So this is basically just like taking the area, so I'm just going to draw out some lines that would make it easier. Sorry for my bad line drawing. Makes it easier for us to find the area. So let's just add all these areas together that are above 0 and then subtract this big area. So this area right here is just a 2 by 1 rectangle. So this part is 2. So let's write this down here. Integral from 0 to 4 of f of x dx equals 2 plus, and then we have this triangle with a base of 2, and this height goes from 1 to 5, so it's a height of 4. And so we multiply the base times height and divide it by 2. That's 8 divided by 2, so this area, this triangle's area is 4. So 2 plus 4, and then we subtract the area of this big rectangle at the bottom. So this rectangle goes from x equals 2 to 4, and it goes from y equals 0 to negative 3. So it's a 2 by 3 rectangle. And 2 times 3, which is base times height, is 6. So 2 plus 4 minus 6. And this equals 6 minus 6, which equals 0. So that's our final answer. And B is 0. So that's our answer. Okay, number 4. We have to find the arc length of ln of x from x equals 1 to 2. So the formula for arc length, L, is equal to the integral from a to b of the square root of 1 plus dy dx squared of dx. So now that we know that that's the formula, y equals ln of x, now dy dx, this is a standard derivative, this equals 1 over x. And so we know that our a equals 1 and our b equals 2, because those are the bounds given in the problem. And so now we can just plug this in. So L equals the integral from 1 to 2, that's our a and b, square root of 1 plus, now 1 over x squared is just the same thing as multiplying 1 over x by itself. So we get 1 over x squared dx. And that's a. A is the only one that fits, so A is our answer. Now, number 5, we have a geometric Maclaurin series. So the formula for this, the sum is n equals 0 to infinity of ar to the n equals a over 1 minus r. And we're going to use that here. So in this case, we don't have an a. So just imagine this a is 1. And so our r, the thing that's being raised to the nth power in our formula, is r equals negative x over 4. So now that we know that a equals 1, we can plug this in. So 1 over 1 minus negative x over 4 equals 1 over 1 plus x over 4. So that's the same thing. That's the same thing as f of x. That's what our series sums to. So now we want to find f of 3. So f of 3 equals 1 over 1 plus 3/4. And so we can rewrite 1 as 4/4. That's the same thing. So this equals 1 over 7/4. And so when we divide by a fraction, we just take its reciprocal. So this equals 4/7. And that's our answer. So C. Awesome. Alright, so number 6, we have another definite integral. So let's let u equal x squared minus 3 from the problem. So that's what's inside here. So now we have to find du dx. This will equal 2x from the power rule. Now we can swap. We can multiply by dx and then divide by 2x to get du over 2x equals dx. So that's what we're going to substitute for our dx in the problem. So this will equal, and then when we divide by 2x, we will take a 1/2 out of the equation and get rid of this x right here. So that's how u sub works. But before so it's going to be u x or minus 3 to the 5th du. But now we have to change our bounds. So we have it from -1 to 4 right now, but u equals x squared minus 3. So -1 squared minus 3 is 1 minus 3, which equals -2. So our bottom is going to be -2 instead of 1, instead of -1. And 4 squared minus 3 is 16 minus 3, which is 13. So our top bound for the integral is going to be 13. And that's our answer. And that is what C is. So we're going to go with C for that question. Alright, so here comes some implicit differentiation. So sine to the -1, x equals ln of y. I'm using sine to the -1 because that's how I like to write it. You can use arc sine if you want to. So now we're going to call back to our inverse trig derivatives. So d dx sine to the -1x equals 1 over the square root of 1 minus x squared. So we're going to use that here. So we're going to differentiate both sides of this equation. So we get 1 over the square root of 1 minus x squared from our rules here. And now we know that the derivative of x is 1 over x, so we're going to write 1 over y. But remember, we don't know what y is, so we should treat y as its argument itself, so we should multiply it by the derivative of the inner argument, which is dy dx. And so now, by multiplying everything by y, we can solve for dy dx. So y over the square root of 1 minus x squared equals dy dx. And so that looks to be A. Boom, there's our answer. All right, number 8. So this is a Riemann sum question. So we're gonna set the Riemann sum up. So RHS, right hand sum, from the problem, right Riemann sum. This equals 6.2 times 7 minus 4 plus 5.9, 12 minus 7 plus 5.6, 15 minus 12. And so this is going to equal, I'll let you guys do this work, but this will equal 64.9. So it looks like we should do A, right? But that's wrong. We're not done. We're trying to find, so let's define a different function. L of t equals the number of liters in the tank. So that's what we're trying to find L of 15. So the number of liters of oil that are in the tank at time t equals 15. We're trying to find L of 15. And so we know that L prime of t is the same thing as R of t. So we can use that in our equation. So L of 15 equals, and we also know from this part of the problem that L of 4 is 50. So we can set up a start plus change problem. Let me move this problem down here. So final equals start plus change. So L of 15 equals L of 4 plus integral from 4 to 15 of L prime of t dt. Awesome. So now L of 4 we know is 50, and the integral from 4 to 15, we found this in our Riemann sum. So L prime of t is R of t. The integral of R of t from 4 to 15 plus 64.9. So 50 plus 64.9 is 114.9, which is C. So that's a bit of a misleading problem, but with a little bit of trickery we can get the answer. Awesome. So number 9 is another series question. Let's do number 1 first. So 8 to the n over n factorial. So what we're going to do for this one is the ratio test. So we're going to take the limit as n goes to infinity of the absolute value, let's put that over everything, 8 to the n plus 1 over n plus 1 factorial. And then we're just going to take a of n. So 8 to the n over n factorial. So let's simplify this a bit. Equals limit as n goes to infinity of the absolute value of. And so we can write 8 to the n plus 1 times n factorial over 8 to the n times n plus 1 factorial. And so 8 to the n plus 1 over 8 to the n just simplifies to 8. So 8's on our top. And for the factorials, we know that n plus 1 factorial equals n factorial times n plus 1. That's just the formula for what a factorial is. So we can use that to our advantage here. We can take out an n factorial and just leave us with n plus 1 on the bottom. So let's put in limit n goes to infinity here. And so that's like the same thing as taking 8 over n to infinity, which obviously goes to 0, which is less than 1. So 1 converges. So we've already eliminated B and C. And so now we only need to find out if 2 converges. So if 2 converges, and also we've eliminated A, and so we need to find out if 2 converges. If 2 converges, it'll be E, and if 2 diverges, it'll be D. So 2 n factorial over n to the 100th. Same thing here, we're going to do the ratio test. So limit as n goes to infinity, the absolute value of, let's move this up here, the absolute value of n plus 1 factorial over n plus 1 to the 100th power over n factorial over n to the 100th. So let's put the value there. So equals limit as n goes to infinity of n plus 1 factorial n to the 100th over n factorial n plus 1 to the 100th. So we can kind of separate these fractions. Equals the limit of as n goes to infinity. So n plus 1 factorial over n factorial is just going to be n plus 1. But that's the definition of a factorial. So then n to the 100th over n plus 1 to the 100th is the same thing as n over n plus 1 to the 100th, which goes to 0. So we're going to write this as over 0, which we can't really do that, but in practice, in a graph, if you try to graph it, it would basically go to infinity. And so this is going to be greater than 1, because infinity is bigger than 1, obviously. So 2 diverges, and so since 2 diverges, it has to be D. D is our answer. Awesome. So 10, we have a definite integral from 1 to 4 of t to the negative 3/2 dt. So here we're going to do a reverse power rule. So if you remember, it's going to be t to the negative 3/2 plus 1, so that's just going to be negative 1/2 over negative 1/2. So we can simplify that to negative 2t to the negative 1/2. And we can also write this as negative 2 over root t. So we're going to write this from 4, or from 1 to 4. So this will equal negative 2 over root 4 minus negative 2 over 1. So 2 over root 4, that's just 2. So equal negative 2 minus negative 2. And, oh, wait. Hold on. I might have made a mistake somewhere. 2 over root t. Oh, oh, this is 1. Sorry, this is negative 1. 2 over root 4, that's 2 over 2. So this is negative 1. And then this will equal to negative 1 plus 2, which equals 1. So E. E is our answer. Sorry, I got a little confused there. So, 11. So this function will be the square root of the absolute value of x minus 2. So the square root function looks a bit like that, right? I'm not very good at drawing. But if we tried to continue it, it would be like this. So when we take the absolute value, we kind of flip this up to this quadrant here. And so it'll be centered at x equals 2, since it's x minus 2 and not x. So 2 here. This will go like the normal square root function, and then this will be flipped according to x minus 2. So this is a corner here at x equals 2. And so corners, you can't really differentiate them because they don't have a slope. You can take any kind of tangent line slope you want, and it'll be valid. So not really differentiable there, but we know it's continuous because this f of 2 will just be 0. So it's continuous. So it's not C, and we know that it is 0 because both sides go to 0, so it's not D. This obviously is not a vertical asymptote because f of 2 is defined, so it's not E either. And since we know it's a corner, it's not differentiable, so it's not B. So it's A. Oops. It's A. Awesome. Okay, number 12, we have a dy dx problem. So let's plug in. So dy dx, let's try this point. So -1, -1. This equals -1 squared minus 1, which is 1 minus 1, which is 0. So since dy dx is 0, and also it's worth noting that if we take dy dx at 1, -5, the second point in the problem, this will equal 1 plus 5, which equals 6. So that's not really helpful here. We can't really do anything with this point, so let's rule out A and B. Let's focus on this first point. So now we need to find d squared y over dx squared to find out if it's a local maximum or local minimum of f. So d squared y over dx squared, this will equal, so now let's just take the derivative. So derivative of x squared would be 2x, and then the derivative of y is just dy dx. But we know what dy dx is from the problem, so this equals 2x plus x squared minus y. Awesome. So now we need to find this at 1, 1, or -1, -1. So this will equal -2 plus 1 minus 1, which equals -2. Okay, so we know that d squared y over dx squared at -1, -1 is less than 0. So what that tells us is from the formula for a local maximum and minimum, hold on, let me find some space. If dy dx equals 0 and d squared y over dx squared is less than 0, y has a local maximum, because this tells us that we're concave down, so this must be the top of a kind of parabola that's concave down. So this is a local maximum, period. And so likewise, if d squared y dx squared was greater than 0, it would be a local minimum, but it's not, so it's a local maximum. So C. Okay, radius of convergence of this series, x minus 4 to the 2n over 3 to the n. So we can kind of make this into a geometric series. We can write this as, we can pull out an n. We can pull out to the n from both parts of the fraction. We can put x minus 4 squared and 3 on the bottom. So now that we have our r, so like ar to the n, remember that's our r, we don't have to find the sum, we have to find the radius of convergence. So we'll set the absolute value of r squared over 3 less than 1, which is the same thing as saying -1. This is between -1 and 1, so x minus 4 squared over 3. And so we can multiply everything by 3 here. -3 is less than x minus 4 squared, which is less than 3. And so negative square root of 3 is less than x minus 4 is less than the square root of 3. We can take the square root of both sides. And this would be complex, but it can't be complex in a series. So, and we don't have to add 4 to everything, because that would not change the interval of convergence, like the actual amount of x values that for the x it will converge. So we'll just ignore this plus 4. And so we know that the diameter of convergence is between -√3 and √3, which is, if you add that all together, that'll be 2 √3. And so since the diameter is twice the radius, we can divide 2 √3 by 2, and we get √3. So C is our answer here. 14, let K be a positive constant, which of the following is a logistic differential equation. So dy dt, this is the formula. This is basically the formula for a logistic differential equation, equals ky times a minus y. So A is going to be our carrying capacity, like it is for all logistic equations. And so the only one that fits this description of ky a minus y is E, which is ky 1 minus y. So all of these other ones either don't have the 1 minus y or don't have the ky. So E is going to be our answer there. For number 15, we have to analyze this graph. So h of x, let's first define all of these functions. H of x equals the integral from 0 to x of f of t dt. Now h prime of x, by the fundamental theorem, this will be f of x. And it follows that h double prime of x is f prime of x. So now we have to find all of these values. We don't have to find them, we just have to compare them at x equals 6 at this point. So just looking, h of 6 is going to be less than 0 because the integral from 0 to 6, all of this is the integral from 0 to 6, all of this is below 0, so it's going to be negative. We don't know the exact value, but it doesn't matter. And so h prime of 6, we can just see that's f of 6, which is 0. So this equals 0. And then h double prime of 6 is f prime of 6. Oops, parentheses. And so the slope at x equals 6 is clearly ascending. So it's a positive slope. So it's greater than 0. So now we can find that h of 6 is less than h prime of 6, which is less than h double prime of 6. So this is A. Awesome. That's a good review for the AP exam. 16, this is an Euler's method question. So what we're going to do, we're going to write dy dx equals x minus y, and f of 1 is 3. So first we're going to establish our x0, y0, and we know from the problem this is 1 and 3. So our x1 and our y1 will equal, since we want to go from f of 1 to f of 2, we're going to use steps of 0.5 because we're using 2 steps of equal length. So our step length is going to be 0.5. So 1 plus 0.5, and then 3 plus, so x minus y, that's our dy dx, is negative 2 times 0.5. So let's simplify this a little bit. Let's make it 1.5 here. Negative 2 times 1/2 is negative 1. So 3 minus 1 will just be 2. Awesome. So x2, y2, that's going to be equal to 1.5 plus 0.5. Oops. And then 2 plus dy dx again. 1.5 minus 2 this time is negative 0.5 times 0.5. And so this left side will be 2. So negative 0.5 times 0.5 will just be negative 1/2 times 1/2, which is negative 1/4. And so 2, which is 2 equals 8/4. So 8/4, and then we add minus 1/4 equals 7/4. So 7/4, that's going to be our final answer. So C. Awesome. So for this one, we have to call back to a bit of knowledge about Maclaurin series. So in particular, sine of x. So if you remember this polynomial, we can derive this, but it's a standard polynomial. So it's alternating and it skips the even powers, whereas cosine x would be alternating with the even powers. Minus x to the 7th over 7 factorial, and so on. So now that we know this, we can see that if we consider option C, if we divide everything by x, so let's just imagine we divide this whole thing by x, we get sine of x over x, which equals 1 minus, we take an x out of here, x squared over 3 factorial, plus we take an x out of here too, x fourth over 5 factorial, minus, and so on. And so that's gonna give us what we want here. So we don't need to consider this part. We can just say that it's sine of x over x. And so C. Awesome. All right. So here's another bit of start plus change here. So f of negative 5. So we don't know exactly what f of x is, but we know what f of 2 is. So this will equal f of 2 plus the integral from 2 to negative 5 of f prime of x with respect to x. And so these bounds are kind of backwards. So let's fix that f of 2. And then we'll just make this negative and switch the bounds over so it'll stay the same. F prime of x dx. Awesome. So we know that f of 2 is 1. And so now let's try to find the integral. So we want to find it from this value to this value. So this triangle, this is going to have a length of 3 and a height of 2. So this will be 3 times 2 divided by 2, which is just 3. So that's our first part. Now this part is a semicircle, and this radius right here is 2. So this is going to be pi times 2 squared all over 2, which will just be 4 pi over 2, which is 2 pi. So equals 1 minus, so 3. 3 is our first part, and 2 pi is our semicircle part, so 3 minus 2 pi. And the reason I put minus is because this semicircle is below 0, so we count as negative here. And so if we distribute out the minus, we get 1, or we get minus 2 plus 2 pi, which equals 2 pi minus 2. And so that's going to be answer A. Awesome. So for number 19, f of x is going to be x over x plus 2. And so we're trying to find f prime of x. We're trying to find when f prime of x equals 1/2. So how we're going to find this is we can use quotient rule. So we'll set this equal to u over v. And so the quotient rule states that this should be u prime v minus v prime u all over v squared. So u prime is just going to be 1. So v is x plus 2, u prime v, x plus 2, minus v prime is also 1, and this is just going to be x, all over, so v is x plus 2, so x plus 2 squared. And so if you'll notice these x's, the x and the minus x cancel out, so this will equal 2 over x plus 2 squared. Okay, so now we need to find when this is equal to 1/2. So 1/2 is the same as 2/4. And so if you'll notice there's a 2 and a 2 on the top here, so we can set the denominators equal to each other. So x plus 2 squared is equal to 4. So x plus 2, so I'm going to split this into 2 equations. So this equals either 2 or x plus 2 equals minus 2. And this will give us 2 different results. So for this one, it'll give us x equals 0. But for this one, it's going to give us x equals negative 4. So it could be either of these. And so that's going to make C our answer. So since it has 0 and negative 4 in the answer. Okay, so 20, this is going to be a partial fractions problem. So let's write this out. So this will be equal to, let's write out the integral, 0 to 1, 5x plus 8 over, and now let's factor this out. This factors into x plus 1 times x plus 2. Awesome. So now we can write this as the integral from 0 to 1 of a over x plus 1 plus b over x plus 2. we'll put brackets around that, dx. So now we'll multiply everything by x plus 1 times x plus 2. That wouldn't change anything. So this will equal, well, this will be 5x plus 8 on the left side. Since we're multiplying by x plus 1 times x plus 2, this will equal a times x plus 2 plus b times x plus 1. So now what we're going to do here, we're going to find x values so that these inner terms will equal 0. So for a, it's going to be x equals negative 2, and for this one, it's going to be x equals negative 1. So let's just say that x is equal to negative 2 first. So this will make that left side negative 10 plus 8, which is negative 2. And then this part will just be 0, so we don't have to worry about a. And negative 2 plus 1 is b times negative 1. So negative 2 plus 1 is negative 1. Now if we solve for b, we get b is equal to 2. So that's our b in this equation. Now we just have to find a. So now we'll set x equal to negative 1. We'll make, so the x equals negative 1, that'll make the left side negative 5 plus 8, or 3. And this will equal negative 1 plus 2, that's 1. So a times 1. So a is just going to equal 3. So now we can rewrite this. We can rewrite a and b as 3 and 2. So now you can use the reverse power rule, or in this case, just a standard antiderivative, to use the fundamental theorem. So we'll do that here. So this will equal 3 times the ln of absolute value of x plus 1, plus 2 times the ln, the absolute value of x plus 2. And this will be from 0 to 1. So when we evaluate this at 1, it's going to be 3 ln 2 plus 2 ln 3 minus, and so ln of 0 plus 1 is ln of 1, which is 0, plus, and then 2 ln of 2. So this will be equal to 3 ln of 2 minus 2 ln of 2 plus 2 ln of 3. So how can we simplify this? This clearly isn't in any of our answers, but we can simplify this. So these ln of 2's we can simplify to just be 1 ln of 2, and then plus 2 ln of 3. So now we're going to employ a bit of log rules trickery. So this will be equal to ln of 2 plus, and then, so this is a log rule, so b ln of a equals ln of a to the b. We use that a lot in logarithmic differentiation, and we're going to use that here too. So this will be ln of 3 squared, which is ln of 9. And so when you have two ln's added together, it's the ln of their products equals ln of 2 times 9, which equals ln of 18. Awesome. And that should be answer C. Great. Number 21, we're going to find a horizontal asymptote. So we want the limit as x goes to infinity to be 5. So we can right off the bat rule out this, because sine functions don't have horizontal asymptotes. They keep fluctuating, and they're like a wave forever. So it's not going to be a, and b is just a linear one. This is not going to have an asymptote. This is just going to be a straight line. For c, this is basically like 1 over x, which goes to 0, so we can rule out that. 1 over x minus 5 doesn't really change the graph that much, so we can rule out c as well. Now, d and e could both be it, because we're going to take high power over high power here. So this will be 5x over minus x, which equals negative 5. But we want 5 to be our asymptote. So the limit is negative 5, but it's not 5, so we can't have d. But e, I mean, we already know it's e, but I'm just going to do it. So 20x squared, we're going to circle the high powers again, over 4x squared equals 20 over 4, which is indeed 5. So that checks out, and it's answer E. So for this power series, a sub n, x minus 3 to the n, converges at x minus 5. So we know that a of n times 2 to the n, 5 minus 3, will converge. And so we know that we'll check the other endpoint. So 1 minus 3 will be minus 2. So we know that that's an endpoint, and we know that 5 converges, but we don't know that 1 converges. So we know that the series converges on 1 to 5. So we don't know about the endpoint at 1. So we're just going to leave it there. So now we can see that all of these, 0 minus 3, that falls out of our range of convergence. So that's not going to be it. X equals 1, that also falls out of the range of convergence. And same thing for C. And x minus 6, well, that's above 1. That's above 1 to 5. So the only one that's between 1 and 5 that we actually know is x equals 2. So it's going to be answer D. Okay, so number 23, this is a differential equation problem. And so linear growth, a linear differential equation, will look like dy dt equals ky. So there will be no independent variable in the equation, and no squared either. So the only one that looks to fit this model is answer D, because we don't want a p squared, we don't want any t's, and we don't just want a number. So we can be confident that it's D. Okay, number 24, this is going to be an integration by parts problem. So the integration by parts formula, so the integral of u dv equals uv minus the integral of v du. That looks like a u, sorry. V du. And so this kind of looks like an integration by parts problem, so we just need to solve for one of the parts of the problem. So let's let u, in this case, equal f of x, and we're just going to we're going to leave du blank because we don't know what f of x is, so we can't find du. So dv, that's going to equal sine of x dx, and so we can find v here. That'll equal negative cosine of x. And so if we plug this into the formula, we get equals negative cosine of x times f of x, which that checks out from this term in the equation, and then minus the integral of v du. So we know that negative, and also we can take out the negative here, so this will just be cosine of x times du. So we know, since we have a cosine x here, we have an integral and an integral, du is going to be 4x cubed. Let's write that in there. And now we can basically integrate 4x cubed. And so to find the antiderivative of 4x cubed. And so that's going to be 4x to the 4th over 4 from reverse power rule, which just ends up being x to the 4th. And that's our answer. So answer E. That's our choice. 25, this is going to be an improper integral. And it looks like we're going to use u sub for this one. So let's let u equals negative x squared. So now du dx equals negative 2x. So we switch dx and 2x around. Du over negative 2x will equal dx. Awesome. So this will just be normal u sub, negative 1/2 integral of e to the u du. But now we have to change our bounds. So we just have to change 1 to negative 1 squared, which will just be negative 1, and infinity, well, negative infinity squared is just negative infinity. So this will be the integral from negative 1 to negative infinity of e to the u du. But notice that these bounds are kind of backwards. We're going from negative 1 to negative infinity. So we want to switch those around, and how we can do that is we can take we can make the entire integral negative. But in this case, we'll make it positive because there's already a negative in front. So this will be the same thing as taking the positive 1/2 integral of negative infinity to negative 1 of e to the u du. So this is going to be e to the u over 2 from negative infinity. That's a really bad infinity sign. Negative infinity to negative 1. So e to the negative 1, that's just 1 over e. So our first term is going to be 1 over 2e. And then e to the negative infinity is basically 0. So this will be minus 0. So it's just 1 over 2e, which is answer B. Awesome. Negative 26. Ooh, man, this is a polar question. So what we want to find here is the slope of the line tangent. So we want to find dy, man, always happens, dx at theta equals 0. So how we're gonna do that is we're gonna use the formula for a polar derivative. So this will be dr d theta times sine theta plus r cosine of theta minus dr d theta cosine of theta minus r sine of theta. That's awesome. So we can plug all this in. So we know that dr d theta, since we have the equation of r in terms of theta, we can just take the normal derivative. And so this will be 2 cosine of theta. So now, and r, of course, will just be 1 plus 2 sine of theta. And also, it's worth noting that sine of 0 equals 0, and cosine of 0 equals 1. That's going to be helpful because theta is equal to 0. So, this will be equal to dr d theta, 2 cosine of theta times sine of theta from our formula, plus, and then let's plug in our r, 1 plus 2 sine of theta times cosine of theta. Now let's make this all over 2 cosine of cosine squared of theta, because we're multiplying 2 cosines together, minus, we'll plug in r again, sine of theta, and then multiply by sine of theta. Awesome. So automatically we can see that any term with a sine of theta in it is we're just gonna ignore it, because sine of 0 at the theta that we want, sine of theta is gonna be 0. So this is gonna be 0, this term is gonna be 0, and this entire thing is gonna be 0. So let's kind of simplify this. This will equal 1 cosine of theta over 2 cosine squared of theta. And so since cosine of 0 is 1, this will equal 1, and cosine squared is the same as 1 squared, which is just 1. So this will equal 1 over 2. And that's all that simplifies down to. So B. Awesome. Number 27. This is going to be a series problem. So we know from our background knowledge that the sum is n equals 1 to infinity of 1 over n to the p will converge for p greater than 1 and diverge for p less than or equal to 1. Okay, so now let's consider I, or 1. So this sum, infinity, 1 over n to the 2p. So let's set 2p less than 1, or greater than 1, sorry, for it to converge. And so p is greater than 1/2. So for all p values greater than 1/2, this one series will converge. So let's do the second series, this one. The sum as n equals 1 to infinity of p over 2 to the n. Now this is a geometric series, so like what we did with the radius of convergence, we can set it -1 is less than p over 2 is less than 1. So -2 and 2 is our bounds. We can multiply everything by 2. So we want a p-value. So for both of these series to converge, we want a p-value that is greater than 1/2 and between -2 and 2. So that'll be between 1/2 is less than p is less than 2. Awesome. And so that's going to be answer C. So last question in the multiple choice part A. So we want limit as x goes to 1 of the integral from 1 to x g of t dt over g of x minus 6. So we know that the top, so limit as x goes to 1 of this g of t dt, this is just the integral from 1 to 1, which is nothing. It'll just be 0. So this will equal 0. And same thing here. So g of x minus 6. So we know from the problem that g of 1 is 6. So it'll be 6 minus 6, which also equals 0. So since we have a 0 over 0 case, we can use L'Hopital's rule and differentiate both of these. We can differentiate both of these equations. So this will be equal to the limit as x goes to 1. So the derivative by the fundamental theorem, this will just be g of x. And then the derivative of the bottom, that'll be g prime of x. And so we can find both of these in the problem. So equals g of 1, which is 6, over g prime of 1, which is 3. So 6 over 3 is 2. And D is our answer. And that concludes the multiple choice part A, no calculator, of section 1. Hope you enjoyed.